you guys, so I need you to take out the packet we were working on yesterday, the one that said ratios and proportions. And we're going to continue with that today. So I asked you to do proportional ratios. You were supposed to solve each proportion for x. We'll go ahead and grade that together when I get back on Thursday, okay? So what you're going to be working on today, the first thing that you're going to do is you're going to flip to your packet to the ones that say create a proportion, and then it says state if each pair of ratios form a proportion or not. Sorry, I'm just looking at it to make sure that I'm on the right page. So let me give you a few example problems so that you know how to do this. If you are going to state if each pair of ratios form a proportion, remember that a proportion just means that your two ratios are equal to each other. They're equivalent to each other. We talked about a few different ways of being able to say that the ratios form a proportion. One of them is that you could find the unit rate for each. You could take the top number, divide by the bottom number, and if you get those two numbers being the same, then it would be a proportion. Or remember, another way that you could do it is you could see if when you simplify the two fractions, if they're equal to each other. And then the third way that we talked about being able to tell whether two ratios form a proportion or not is by using the cross products. And that's the way that I would like you to do this particular assignment, okay? So to state whether these ratios are a proportion or not, you're going to find the cross products. So you're going to go 3 times 16, which is 48, and then you're going to do 8 times 6, which is 48, and because those two cross products do equal each other, you would say yes, these two ratios form a proportion. These two fractions are equivalent to each other, basically. Okay, number 2, if we do the cross products for 4/7 and 8/21, 21 times 4 is 84, and then 7 times 8 is 56. Because 84 and 56 are not equivalent to each other, we would say no, these ratios do not form a proportion. Okay, so all you're doing on that particular part of your homework is you're just saying yes or no if the ratios form a proportion or not. Okay, on the bottom part of that homework, you're actually going to be creating a proportion and then solving it to figure out the thing that you don't know. So you're going to first create a ratio, and then you're going to use that ratio to set up another ratio. Those two ratios equal to each other will form a proportion. So let's go ahead and look at number 1. And these are just sample problems that are just like your homework. So they're not your actual homework problems. I just pulled a few in that I can show you as an example. So this number 1 says, 1 cantaloupe costs $2.50. How many cantaloupes can you buy for $15? So our ratio is going to be that 1 cantaloupe costs $2.50. Okay, so now we put the number of cantaloupes on the top and how much they cost on the bottom. So remember, when we set up our next ratio to make our proportion, we have to make sure that the units match. So, okay, so now when it says how many cantaloupes can you buy for $15, that means we want to put the number of cantaloupes is what we don't know for $15. And then once you have your proportion set up, the way that you're going to solve these proportions is you're going to cross multiply. So 15 times 1 is 15. 250 times x is $2.50 times by x. And then you guys know when we have an equation that looks like this, if we want to get the x alone, we have to get rid of the multiplication of $2.50. So we're going to divide 15 by $2.50. So we're going to take 15, we're going to divide by 250, and we're going to get a 6. So you can buy, if 1 cantaloupe costs $2.50, you can buy 6 cantaloupes for $15. Okay, let's look at another one. You can buy 5 cans of green beans at a supermarket for $3.40. How much does it cost to buy 35 cans of green beans? So our ratio, or our rate, is 5 for $3.40. And we want to know how much does it cost. So in our ratio, remember we did cans of green beans over cost. So in our second ratio, we want to do the cost on the bottom and cans of green beans on the top so that the units match in our ratios. And now we have a proportion. So the way to solve a proportion is you cross multiply. X times 5 is 5x. $3.40 times by 35 is 119. So we're going to take that 119 and then we're going to divide by 5. And then that will tell us how much it's going to cost for 35 cans of green beans. So that's going to be $23.80. Okay, so that's a couple of examples for you for how you're going to do the bottom part of that page. And then the next page deals with similarity and ratios. So you guys learned about similar figures when you were in 6th grade. So if two figures are similar, that means that their angles are equal to each other and their corresponding sides are proportional. So if we are going to write a ratio to figure out the missing side, we have to make sure that we're using corresponding sides to do that. So the side directly across from your right angle, that's the longest side, and it's called the hypotenuse. Okay, so in these two triangles right here, we can see that this side right here corresponds with this side right here. So if we were to flip this triangle right here up and face it the same direction as the other one, we would see that these two sides, the 15 and the 5, correspond with each other. And then the other two sides, the 3 and the 4 on the smaller triangle, those are called the legs. So you can see that the smaller leg is 3 on this triangle and the smaller leg on this triangle is 9. And you want to find the missing side length, which is this one right here, and it's the longer leg, and its corresponding side is 4. So there are a bunch of different ways you can write proportions for this. I'll show you a few of them. You just have to make sure that when you do them, you use corresponding sides. So we want to know the longest side's leg. So the longest side's leg over the length of the longest side on the smaller triangle. That would be x over 4. Okay, so this side right here, it corresponds with this side over here, so we're going to set that up as a ratio. And then we could use the shortest side of the bigger triangle and the shortest side of the smaller triangle. So that would be 9 over 3. So just remember that we did big to small, right? So we have to make sure on this one that we also do big to small. Okay, so that gives us a proportion. We could also do x, so the longest side over the shortest side equal to the longest side of the hypotenuse over the bigger triangle's hypotenuse over the smaller triangle's hypotenuse. So that would work. We could also do the 4. Sorry, you guys, I need to back up. So if we do this side right here, x over 9. Sometimes when I'm doing these videos, I get a little bit lost. Okay, so if we're doing x over 9, we just did the longest leg over the shortest leg. Then we have to do corresponding sides. So we have to do the longest leg of the smaller triangle over the shortest leg. Okay. We could also do the 4 over x, so the smaller triangle longest leg over the bigger triangle longest leg equal to the smaller triangle shortest leg over the bigger triangle longest leg. There's like quite a few different ways that we can set up our proportion. Now, once we do that, we just need to cross multiply. Notice here that when I cross multiply, I get 3x equals 36. Notice here, when I multiply, I get 3x equals 36. Notice here, when I cross multiply, I get 3x equals 36. So there were a bunch of different ways that we could set up a proportion. We just had to remember to do that with corresponding sides. And then notice that our equation's the same on all of these. So our x is going to be 12, no matter which proportion that we used. Okay, so let's try it for these two similar triangles. So this is the side we don't know. And I'm going to color these in, okay? So this side right here corresponds with this side right here. And this side right here corresponds with this side right here. So if I want to do ratios of the corresponding sides, I'm going to do 9 over x, so bigger triangle to smaller triangle, is equal to bigger triangle over smaller triangle. And then we just cross multiply. Okay, and like I said, you can set up your proportion in a different way, and as long as you keep it ratios of corresponding sides, in the end, you will still get the same equation and then answer, because we would divide by 12 on both sides. So x equals a 3. Okay, let's do one more. So we can see that this side corresponds with this side, and we can see that this side corresponds with this side. So when we set up our proportion, we're going to do small to big is equal to the small that we don't know over the big. And then we just cross multiply. Okay, so that's how you're going to do that one. And then the last one, okay, and then the last one that you're going to do is 4.3c homework, odds and probability, and it's going to be on chance proportions. So it says set up proportion equations to find needed information to answer the questions, draw models, or make tables if desired. Okay, so you guys have the entire rest of the class period to work on finishing those 3 homework sheets. And I need them done before the first of class on Thursday. Okay, so we'll go ahead and grade these together on Thursday. Okay, talk to you then.